Hello students, in this class we will learn about remainder theorem. So before learning remainder theorem, we have to learn the utility of using remainder theorem. Okay, so why we have to use remainder theorem and how remainder theorem can help us to find the remainder when a polynomial is divided by another polynomial. Okay. So before learning remainder theorem, we will take an example. Here we have to divide x cube minus 3x square plus 3x plus 3 by the polynomial x minus 1. So to divide this polynomial x cube minus 3x square plus 3x plus 3 by x minus 1, we follow long division method. By long division method, to bring x cube, we have to multiply this x by x square. So x into x square is x cube. That is why in the quotient there will be x square. X square into x will give x cube, minus 1 into x square will give minus x square. After subtracting, we have minus x cube plus x square. After cancelling this x cube, we have minus 2x square plus 3x plus 3. Now, to get minus 2x square, we have to multiply this x by minus 2x. X into minus 2x will give minus 2x square. So, in the quotient, there will be minus 2x. And after multiplying this minus 2x with x minus 1, we have minus 2x square plus 2x. After subtracting, we have plus 2x square minus 2x. We can cancel this minus 2x square and plus 2x square. And after subtracting this, we have x plus 3. Now x into 1 will give x. So in the quotient there will be plus 1. This becomes x minus 1. After subtracting, we have minus x plus 1. You can cancel this plus x minus x, and last of all we have 4. 4 becomes the remainder. So when x cube minus 3x square plus 3x plus 3 is divided by x minus 1, then by long division method we have 4 as the remainder. Okay. Now we will learn what remainder theorem states. So what is the statement of remainder theorem, and then how we can use this remainder theorem to get this remainder 4. Okay. So let us study about remainder theorem. Statement. Let f of x be a polynomial of degree 1 or more, and a be any real number. When f of x will be divided by x minus a, then the remainder will be f of a. Okay. So this is the statement of remainder theorem. This remainder theorem states that when a polynomial f of x whose degree is 1 or more and a be any real number, then when f of x is divided by x minus a, then the remainder will be f of a. Okay. So now we will study how we can prove this remainder theorem. By division algorithm, we can write f of x is equals to q of x into x minus a plus r of x, where q of x represents a polynomial of any kind of degree where q of x represents a polynomial of any kind of degree less than the degree of f of x, known as quotient. Okay, that is qx is also a polynomial whose degree must be lesser than degree of the polynomial f of x, and it is also known as a constant. Okay, and r of x represents a constant polynomial as its degree is less than the degree of x minus 1. Thus, we can say that r of x is a constant polynomial. Let r of x equals to r. Okay. Now, f of x becomes f of x equals to q of x into x minus a plus r. This becomes number 1. Replacing x by a in 1, we get f of a is equals to q of a into a minus a plus r. This implies f of a equals to q of a into 0 plus r. So this implies f of a is equals to r. that is the remainder R is equals with f of a, which concludes the remainder theorem. Okay. So by this way we can prove the remainder theorem. So remainder theorem states that when a polynomial f of x whose degree is 1 or more is divided by a polynomial x minus a, where a is any real number, then the remainder is f of a. Okay. Now we will learn how we can apply this remainder theorem to find the remainder. So we can follow this problem where f of x is x cube minus 3x square plus 3x plus 3. Example 1. Here f of x is equals to x cube minus 3x square plus 3x plus 3. And x minus 1 is like x minus a. So a is equals to 1. When f of x is divided by x minus 1, then by using remainder theorem, we get remainder is equals to f of a equals to a means 1, so f of 1 is equals to 1 cube plus 1 cube minus 3 into 1 square plus 3 into 1 plus 3. This will give 1 minus 3 plus 3 plus 3. Cancelling plus 3 minus 3, we have 1 plus 3, 4. So 4 becomes the remainder. So this remainder 4 and this remainder is also 4. So these two are remainders, same remainders. So by this way, that means using remainder theorem, we can easily find the remainder when this polynomial f of x equals to x cube minus 3x square plus 3x plus 3 is divided by x minus a, x minus 1, sorry, x minus 1. Okay. Sometimes there will be not in the exact form of x minus a. So if there is not in the exact x minus a form, then how we can find a? Okay. So when there is not exact form of x minus a, then how we can find A. The following procedures will help us to find A. When a polynomial f of x is divided by x plus p, then A is equals to minus p. Since x plus p is equals to x minus of minus p, and comparing with x minus a, we have a equals to minus p. Okay. Number 2, when a polynomial f of x is divided by px plus q, then a equals to minus q by p. Since px plus q is equals to p, taking out p as the common factor, we have p into x plus q by p, and then comparing x plus q by p with x minus a, we have a is equals to minus q by p. Number 3, when a polynomial f of x is divided by px minus q, then a is equals to q by p. Since px minus q is equals to, taking p as the whole common factor, we have px minus q is equals to p into x minus q by p, and then comparing with x minus a, we have a equals to q by p. Okay. So these are the 4 different forms where we have to find a. Okay. So when If this polynomial f of x is divided by x plus p, then a will be equals to minus p, as x plus p can be written as x minus of minus p, and comparing with x minus a, we get a equals to minus p. Number 2, when a polynomial f of x is divided by px plus q, then a is equals to minus q by p. Since px plus q can be written as p whole into x plus q by p, and then comparing this x plus q by p with x minus a, we have a equals to minus q by p. And in number 3, when a polynomial f of x is divided by px minus q, then a is equals to q by p. Since px minus q is equals to p whole into x minus q by p, and then comparing with this, then comparing with and then comparing x minus q by p with x minus a, we have a is equals to q by p. Okay, so these are the three different forms where there is no direct form of x minus a. Then how we can calculate a? Okay, let us study example 2. By using remainder theorem, find the remainder when the polynomial f of x equals to x to the power 4 plus 2x cube plus x square plus 1 is divided by 2x plus 1. So we have to, by using remainder theorem, we have to find the remainder when the polynomial f of x equals to x to the power 4 plus 2x cube plus x square plus 1 is divided by 2x plus 1. Solution. So here 2x plus 1 is equals to 2 whole into x plus half. So comparing this with this form px plus q, we have here 2x plus 1 is equals to 2 whole into x plus half, imply a is equals to minus half. Since 2x plus 1 is like px plus q. So therefore, by using remainder theorem, the remainder equals to f of a is equals to f of minus half is equals to minus half whole to the power 4 plus 2 into minus half whole cube plus minus half whole square plus 1 is equals to 1 by 16 plus 2 into minus 1 by 8 plus 1 by 4 plus 1. Cancelling, we have 1 by 16 minus 1 by 4 plus 1 by 4 plus 1. This can minus 1 by 4 plus 1 by 4 can be cancelled out. This will give 1 by 16 plus 1. So 16 becomes the LCM. We have 1 plus 16 in the numerator. So 17 by 16. This becomes the remainder. So this is the example where we learn how we can find the remainder when the polynomial f of x equals to x to the power 4 plus 2x cube plus x square plus 1 is divided by 2x plus 1. Now we will learn how we can apply remainder theorem. Okay, so to learn the application of remainder theorem, we consider a problem. The problem states that there are two polynomials. They are ax cube plus 4x square plus 3x minus 4 and x cube minus 4x plus a. So these are the two polynomials. When these polynomials are divided by x minus 3, then they leave same remainder. We have to find the value of a. Okay. So first of all, we have to consider these two polynomials by some expressions. Solution. Let the given polynomials be f of x equals to ax cube plus 4x squared plus 3x minus 4 and g of x equals to x cube minus 4x plus a. When the polynomials f of x and g of x are divided by x minus 3, then by the remainder theorem, remainders will be f of 3 and g of 3 respectively. Okay. So first of all, we consider the given polynomials as f of x equals to ax cube plus 4x square plus 3x minus 4 and g of x equals to x cube minus 4x plus a. So when these polynomials f of x and g of x are divided by x minus 3, then by the remainder theorem, remainders will be f of 3 and g of 3 respectively. Now by the problem, these two remainders are equal. So by the problem, f of 3 is equals to g of 3. This implies f of 3 means a into 3 cube plus 4 into 3 square plus 3 into 3 minus 4 equals to 3 cube minus 4 into 3 plus A. This imply A into 27 plus 4 into 9 plus 9 minus 4 is equals to 27 minus 12 plus A. This will give 27A plus 36 plus 5 equals to 15 plus A. So this imply 27A plus 41 is equals to 15 plus A. This will give 27A minus A is equals to 15 minus 41. This imply 26A is equals to minus 26. This imply A equals to minus 26 by 26. After cancelling these two 26, we have A equals to minus 1. Okay. So this is the application of remainder theorem, where by using remainder theorem we find the value of A. Okay.